Thank you for joining us. Daniel Wertheimer, lead data scientist at Absa, is going to take us through the presentation entitled A Dive into What Best Practice Data Science Looks Like and Why It Might Look Different for You. Sounds like a very interesting topic. Daniel is a lead data scientist and machine learning engineer at Absa, where he leads and supports a global team of data scientists and engineers to deliver solutions across the group. His commitment to discipline and personal growth led him to be acknowledged globally as a 30 under 30 future data and analytics leader. Then, great to see you once again. We had a wonderful chat last year where you were showing some use cases of how ML is being used at Absa in your environment. Today, you want to give us some data science principles. And, yeah, we look forward to your presentation. I'll hand over to you now.
Awesome, thanks, Sinzele. I can't remember if I gave that bio or not because it sounds so self-congratulatory. I was like, I'm a little bit self-conscious now.
Don't worry, everything is open. You're an open book, so you can't hide it from me.
Thanks, Sinzele. Cool, yeah. So as Sinzele mentioned, Daniel Wertheimer, I am a data scientist at Absa. And maybe to just give a little bit of context into how data science kind of works at Absa, at least within my team. We serve as a center of excellence within the Chief Technology Office for the entire group. So I'm not the leader of the center of excellence. There's a guy named Adam Smitchek who's in charge of that. But we're structured around a few key pillars. Some of them being project related, some of them being tooling related. So we have two teams that look after our platform and tooling. So platform being things like DevOps, MLOps, the stuff that Axel spoke about previously. And then tooling who work on building tools to help enable data scientists to kind of do their job better. And where I fit in is I kind of lead a team and we look after data science for the entirety of the retail bank. So that's kind of where I fit in. And this session, I'd like to be pretty interactive. So if you have any questions, comments, anything, please kind of put them in the chat. But I think firstly, my first question to the crowd, and please raise your hand if you have ever Googled best practice data science. I'll give this like 10 seconds, just hit the raise your hand button at the bottom. Let's see. Connor, I see you. There's only one person that's Googled best practice data science or best practice analytics, anything. Musa, I see you. I suspect that it's I see a thumbs up at the bottom there. Cool. So the next question then is, who has built a strategy for best practice data science? So who went and said, okay, I'm going to go look at Google and try and identify what best practice is, and then I'm going to try and build some strategy to kind of put it into place. Axel, yeah, I can see that you've really thought this one through, and I don't think that you fit into this presentation. I'll tell you why now. And then the last question is, who has implemented best practice data science? And this is an interesting question because, the question is, what is best practice actually? And, this is a definition of best practice, saying that, it's a method or technique that has generally been accepted as superior to any alternatives, because it's just the way that we do things, right? So if you came into this talk thinking that I would show you pictures like this, this is Monzo's machine learning stack, or, pictures like this one, which is Netflix's, or, pictures like this one, which is ours. It's not actually classified. I've spoken about this a few times. And I'm happy to chat to anyone about what we're using, offline. If you thought that was the case, then I'm sorry. That's not what this is. This is about. And I'll get into that right now. To set the scene, right? Fortune Business said that moving into 2027, the global AI market value is going to reach $267 billion, which is a enormous amount of money, right? And that $267 billion market value is not just going to be realized from people utilizing AI and data science and machine learning and so on. You'll see that there's new startups, new platforms, new companies, new technologies, and there's new ones popping up all over the place. And, if we look at Gartner's research in terms of the hype cycle for data science and machine learning last year and this year, we'll see that, if we look at these kind of areas where the things are just starting to kind of, plateau out in terms of their expectations and what we know about them, notebooks have only reached that stage now, right? 2020. Predictive analytics is kind of only there now. And the more concerning thing and the part that where best practice fits in is this area here, where we have these innovation triggers, peaks of expectations, troughs of disillusionment. And the way to think about this is, these innovation triggers and peaks of inflated expectations. These are areas where you're going to see a lot of the new players coming in. You'll see, some really topical things at the moment. Things like explainable AI, things like MLOps. Axel spoke about that just now, and feature stores. These are some of the big things, and as you see the hype grow for these things, you see more and more people trying to get in on the train, more and more talks about this, trying to say, we've solved this and so on. And then as things kind of fall off, for example, when we look at things like advanced image and video analytics in this trough of disillusionment, that's effectively saying that this is where things shift to say, we haven't solved this. We start saying this is now really difficult, and we can help you along the journey. And that narrative shifts, but it's still, we still need to be able to discern. So what I'm effectively getting at is it's important now more than ever to disseminate what the hype is in terms of data science and AI and machine learning from what's sustainable in terms of the implementation component. So if we come back to that question around building a strategy for best practice data science, we realize that the problem itself, in terms of what we need to accomplish for, getting data science over the line, is less about the strategy, right? We know at a high level what we need to do. The problem is effectively, what do we do? How do we execute within the context of the organizations and companies that we find ourselves in. And a great way to think about this is Tebogo Mokgo, I think that's how you pronounce his name. He's the ex-COO of Airports Company South Africa, and he kind of refers to every company as a raging river, right? And no raging river is the same. And what you need to get across that river or kind of stay afloat there in that river differs. And you need to consider how you need to navigate your raging river. And the first thing that you should be doing is identify the gaps that you have in terms of the actual operationalization of data science and machine learning. So, for example, if we were to consider the entire machine learning lifecycle, and we look at it from a very high level, there's things like the actual problems that we're trying to solve, things like data preparation, things like model fitting, inference and deployment. At a high level, where do we see the largest amount of gaps, right? An example might be, in our case, that we had a really big problem in the inference and deployment case. And when we narrowed down to find out what the core problem was, we realized that the data flows, at least within Absa, have a very irregular cadence. And because Absa Amalgamated Banks of South Africa, we're like legacy. I think we're 13 different banks, all like amalgamated into one institution. So legacy is huge. And data would arrive at random times, not at the same time every day. Sometimes data would be missing. And this is like a huge problem for data science and machine learning. We don't want our production models to run on incomplete data or missing data or anything like that. And so we needed to solve that, and we identified that as a gap. Obviously, then we went through the stage of, what is best practice in terms of ingestion. And we kind of found tools like Airflow and cron in terms of scheduling, but none of those solved our problem. And then we had to go through a process of identifying what we could do next. But when it comes to best practice, or at least trying to identify best practice, I think that there's 3 principles that you should consider within the context of your organization. 1, reusability. 2, autonomy. And 3, your people. Right? And we'll go through these one at a time. So when I say reusability, I'm talking about assets that currently exist that we can make use of. And I'm not talking about just within your organization. I'm talking about globally, right? There's a massive open source community. And nowadays, even the big companies that are putting out paid tooling are releasing that same tooling as open source tooling that you can implement yourself. A good example is for experiment tracking and model monitoring. MLflow is the thing, which was released by Databricks and as a part of their kind of Databricks offering, but they give it out for free, and it solves a very specific problem and one that's very relevant. So try and identify those kind of use cases. And a good example is in this case is in our journey at Absa, most of our data moves onto Kafka. And that's kind of where it's consumed from in some cases. In other cases, it's consumed from Hadoop. So for those that aren't too familiar with Kafka, Kafka is a real-time streaming platform. Effectively, you can think of it as a pipeline. You put your results onto it and it moves through this pipe. And people can pick up the stuff from this pipe along the journey. Now, we can put our data there, but Kafka is not a place where you store information. Right? You don't want to store your data there because there's something called a retention policy. So we only retain data on Kafka for 7 days. So we needed to offload our data onto our strategic platform, Hadoop. And to migrate your data from Kafka onto Hadoop is a nightmare, right? And to do this multiple times is a nightmare. And I'm going to plug Absa open source software here, because we developed a tool called Hyperdrive, not within our team, within the broader Absa structure, which is a user interface driven way of offloading data from Kafka into Hadoop. And it takes about 1.5 minutes to set that up. So instead of spending a developer's time building that workload, 1.5 minutes and click a run button, schedule it, and we're good to go. The next aspect being autonomy, and this is something that I'm quite passionate about, and I think moving into the future we'll see this change. But at least right now, we expect data science, and I'm going to speak very specifically in terms of Africa and the conversations that I've had. We're not at a point in time where people can the data science as a person can focus on a single part of the entire life cycle. They're expected to kind of work across it. And we want to make sure that they are enabled to work across that entire life cycle. So when you start putting into place, processes and patterns for doing data science across that full end-to-end life cycle, consider ways in which you can enable people to do that, right? To own the different parts. A good example of this is solving that specific issue that we had with our ingestion patterns. The data science work, in terms of the ingestion side, is not necessarily a data science problem. It's more of an engineering problem, data moving from A to B. But what we have built is a tool called SyncWatcher, which is soon to be open sourced. So check it out as soon as it is, and I'll post it on social media. Excuse me. SyncWatcher. Excuse me. SyncWatcher. We basically built an ingestion tool that manages all the dependencies for you and does all the ingestion jobs and will fire off any downstream processes. So what happens if data is late? It will check if data is available. If it's not, it doesn't run any dependent jobs. And once the data becomes available, it will consume it and run those jobs that are dependent on it. And what's amazing about this is that it's all config driven. So data scientists don't need to, and again, it's built in Scala, and data scientists do a lot of work in Python. So, that's not really ideal, but we made it config driven. So you just write a config file, very easy to do, and you set up your job. And we enable the data scientists to kind of run that entire pattern. So that's one example. We've done this multiple times across the value chain. And then lastly, your people are effectively your biggest asset, right? And there's this concept called Ikigai, which is the intersection of what you enjoy, what you're good at, and what you find purposeful. And something that we're trying to do, and I encourage people to do, is put people at that intersection, and then invest in cross collaboration of those people. A good example of this is, hiring is another thing altogether, right? But hire for the future and not what you need right now, right? And what I mean by that, and take that with a pinch of salt, because in some situations you may need to hire for right now. But a good example is we managed to hire an incredible engineer because we needed an engineer right now. But what was the most important thing about that engineer was that they didn't want to be an engineer anymore. They wanted to be a data scientist. So right now, that person is busy doing incredible engineering work and building a lot of tools and getting the exposure to data science. And we're that is kind of like what we needed in the future, because we've got a very strong engineering base right now, but data science is kind of like our second bread and butter in terms of our skill set. So it's a kind of that cross collaboration and team effort. If we go back to when we first built this team, we were 3 people, which is really small, and now we've grown to about I think about 14 people over the last 2 years, which is amazing. And I think one more thing to mention about this, because I'm looking at the time, is that too often organizations put a focus on career progression being purely managerial. And the people that are going to be most important in terms of maintaining your data science capability and maintaining, I guess, the best practice are the people that are those technical, very strong people. So really consider how you can promote and reward people from a technical perspective without putting them into roles that they don't want to be in. But that's a topic for another discussion. So to recap, next time anyone brings up best practice, put it into the context of the organization that you're in, and remember the principles. And if you want to come and chat to me about this, come and chat about Absa. Very happy to. I'm going to plug Absa again. We are hiring. We're looking for data scientists. I think I'm going to put it out there. We don't have any experience requirements in our team. We just want smart people that understand data science and are willing to learn. If you want to contact me on LinkedIn, scan the QR code, add me. Thank you. And yeah, open for any questions.
Thank you so much, Dan. Very interesting stuff there. You spoke about the potential that the global market for AI has. 267 billion estimated market growth market by 2027, which is quite massive. I think you spoke about something interesting also, the reusability, which I think if 80% of the problems that I want to solve, someone has already solved something similar, then I have no reason not to, participate in the space. So awesome. Thank you so much. I'll see if there are any questions here. Okay, I think Connor. Hi, Connor. Connor is a very good friend of mine. We recently interviewed him about AI and ethics. He says, how often do you consider sustainability within your data science practices? For example, the environmental cost of running practices on potentially a vast amount of electricity.
That's a really good question. And I think the answer is not enough. And I think that the answer generally is probably not enough either. It's only very recently become something that is, popular in the research. Sustainability, the impact of large language models and all this stuff. I think it's going to be something that becomes more prevalent. As we move into the cloud, it's going to become more difficult to do this because we're not fully in the cloud just yet. The one thing that I can say is that nothing that we're building in terms of like modeling is all that big. But in the future, it's definitely going to be relevant. I think, a lot of places are now going to be using, things like these large language models developed by OpenAI, Google, and so on, which have massive environmental impacts, and it's not measured. And I think it's definitely one of those things that's going to start coming up in the future.
Okay. Dan, thank you so much. Really appreciate. Now we're going to go to our last presentation before we go for lunch. So please stay with us. Do not go away. We'll be back shortly. Thank you.